Hi, my name is Meg. Alex, Lydia, Melanie, and I teamed up for this project to run a small-scale study for our statistics class. We applied some of the methods we learned in class to a real-world problem that many college students face: the frustrating cost of textbooks. We took a look at the estimated costs of admission breakdown given by Portland State University and used this information to compare to a set of data we collected by surveying PSU students. To set up and perform a statistical evaluation of PSU's estimated textbook costs, we used an online survey format to gather anonymous data. The link was emailed to the students enrolled in our statistics class. We asked for information about a student's age, how many credits they are enrolled in, and how many textbooks they were required to purchase for their classes this quarter. We also asked questions about the students' spending habits when purchasing textbooks, including the type of book they typically purchased and where the student made the majority of their textbook purchases. Finally, we asked the survey participants to give their best estimation for how much they spent on textbooks for the spring 2016 quarter. Here's a look at what PSU says you should expect to pay for a 3-term academic year. Since we focused on a single quarter, we divided the PSU estimated cost by 3 and came up with an estimated cost per quarter of $421. We collected 32 responses from our survey. We performed a hypothesis test for means. Melanie will walk you through our calculations.
We used a t-test to compare the mean textbook cost from our sample data to the PSU textbook cost estimate at a standard alpha of 0.05 significance. This is the formula used to find the test statistic by hand. We used calculator shortcuts to find the descriptive statistics for our sample data and to complete the t-test. We entered the data for the estimated textbook costs from our survey data into a list. To find the sample mean and the sample standard deviation, we used the calculator program 1var-stats, which is found using the key path, stat, arrow over to calc, arrow down to 1var-stats, hit the enter key, and type second L1. The calculator returns the sample mean, x bar, and the sample standard deviation, s. X bar was equal to 143.44, and s was equal to 94.29. Next, we performed a t-test using the key path stat, arrow over to test, then arrow down to t-test. The calculator returns the test statistic and p-value. T was equal to 8.61, while p was equal to 1.01, 10 to the negative 9. As our p-value is very small, we would reject the null hypothesis. We determined that there is enough evidence to support the claim that the mean textbook cost for PSU students for one quarter is different than the PSU estimated mean of $421. We collected several pieces of data in our survey because there are many different variables that could potentially correlate with how much a student spends on textbooks. For example, a student who is required to purchase many textbooks are likely to pay more than a student with fewer required textbooks. Alex is going to jump in to show some of the interesting things we found when we looked closer at our data.
We also created a scatter plot using SPSS to compare the number of credits taken by a student to the amount they spent on textbooks this term. The scatter plot's visual representation of the data did not reveal any patterns within the dataset. To be sure that the number of credits did not correlate with how much students spent on books and supplies, we decided to also run a linear regression using SPSS. On the slide, you can see that the result for the R value, which signifies whether or not the variables correlate, is 0.242. Because it's so close to 0, this signifies that our data did not show a correlation between the number of credits taken and the cost of books.
Our results were not able to provide any form of correlation conclusions. While it is possible that no correlations exist between the variables we selected, we believe that our survey methods contain several areas where potential errors affected our results. To improve the study, we suggest sampling a more specific group and a more controlled population to reduce the influence of other variables. One way to do this would be to limit the sample to one specific class where the sampled students all have the same required textbook to purchase. In this way, data collected would reflect only the variation in a single textbook cost that could be compared to variables like the type of book purchased to examine if significant correlation exists. Although the population mean we compared our data to was also an estimation, our request for sampled students to estimate their textbook costs leaves a wide possibility for estimation error. For the most accurate results, it would be best to ask sampled students to report the exact amount that they spent on a textbook. Performing the survey closer to the beginning of the term would likely increase the accuracy of reports as well.
Even though we found data that did support our prediction that the true mean cost of textbooks for one term at Portland State University was different from the PSU cost of attendance estimation, the additional data collected on the variables that we examined for possible correlations did not support our initial thoughts that correlations may exist. While we would have liked to have reported that significant correlation supported our personal predictions, we also believe that our study design weakened the ability to accurately study our variables. Studies like ours are still valuable to the development of new studies by demonstrating areas where future researchers can increase the validity of their own findings.